Hello students, welcome to the logarithm part 2. So first here we will revise the formula which we have derived in the first part. That is first is log m into n to the base a is equal to log m to the base a minus plus log n to the base a. First formula. Second formula similar to this, log m divided by n to the base a is equal to log m to the base a minus log n to the base a. Now come to the third formula. Log m to the power n to the base a base and that is equal to n log m to the base a. Now come to the fourth formula. A to the power log m to the base a. So if this one and this one is same, that is equal to m. Now base change formula. Log p to the base a is equal to, you can introduce any base. Of course, that should be defined. That means that should not be equal to 1 and less than 0. So here log b to the base c divided by log a to the base c. And here you can further derive log b to the base a is equal to 1 by log a to the base b. This is the fifth and this is the sixth. Now seventh, log 1 to any base. Log 1 to any base a, anything that will be equal to 0, and if log a to the base a, if both are same, then this is equal to 1. This is the eighth formula that you have to remember. So that mugging up exercise you will have to do. Now we come to the logarithmic inequality. See, a is greater than 1. A can be less than 1 also, between 0. But here a is greater than 1. A cannot be equal to 0. That is there. So if a is greater than 1 and m is less than n, so this one is less than this one. So log n to the base a will be greater than log m to the base a. For example, here log 30 to the base 10, here log 20 to the base 10. So 20 is greater than 30, so this log will be greater than this log. So this is very important because from that we can solve this problem. That how many digit will be in 20 to the power 10. So just you see, log 1000 to the base 10 is equal to 10 to the power 3 to the base 10. That is equal to 3 log 10 to the base 10, and this is same, so that is equal to 3. And log 10 to the 10 to power 4, 10,000 you will take. Then what will happen? That will come to be 4. So anything in between 1000 to greater than 1000 and less than 10,000 will be only 4 digit number. 4 digit number. And what will be the value? This is 3 and this is 4. That means 1000 will be 10 to the power 4. This is 3 or this is x. And the x can be anything between like 999, 3 digit number. So if it is, this is a 4 digit. So 4 digit number, any 4 digit numbers. If any 4 digit number, this will be between 3 to 4. So if any log we are getting, suppose we are getting 3.4, we can safely can say that this number is 4 digit number. So this property will use here. Now we have to find out the number of digits in this number. So this is log 10 to take and 20 to the power 10. So that is equal to 10 log 2 into 10, 10. So that is equal to 10 into log plus 2. So this one is equal to 1 and this one is equal to 0.3. So that is equal to 0.301. So that will equal to 3 10 into 1.301. So that is equal to 13.01. So 13.01, that means this number will be 14 digit number. 14 digit number. So this will be 14 digit number. So this is the application of logarithm. Now we'll solve so many questions. See, see, here this one is less than 1. This one is less than 1. So if it is more than this one, 30 is more than 20, so it will be lesser. So just opposite to previous one. Previous one, A was more than, this was more than 1. And here it is less than 1. So less than 1, M is greater than N, then it will be just opposite to that. Now is the second inequality. Now come to the third inequality. See, A and M both lies on same side of the A and M both lies the same side of the unity. Same side of unity. So this also should be less than greater than 1. This also should be greater than 1. So this will be greater than 0. If lies same side of the unity, same side 0.1, here is a 0.3. This will also greater than 0. Now come to fourth inequality. If different side of unity, see here different side of unity. See is a less than 1 and this is a greater than 1. So different side of the unity. So this will be less than 0. That means this one will be negative. It is a negative number. And this is also negative number because this is greater than 1 and this is less than 1. So this also will be negative number. This is the fourth equality. Now we solve some questions. So here we can write 9 into 8. That means 3 to the power 2 multiplied by 2 to the power 3, which we can write 3 to the power 2 plus 2 to the power 3. So that is 2 log 3, 3 log 3 log 2. So this is the answer. Now evaluate this one. ln, wherever ln is there, then the base is always e. So if ln 5 you will written, then you understand it is written log 5 to the base e. And if it is given log 5, then you understand the base may be 10. In calculus, generally we take e, and otherwise some ambiguity is there for log. But for this, there is no ambiguity. Ln 5 means 5 log 5 to the base e. So here log 9 to the base e minus 4. So here 3, 3, 2 minus, so 2 log 3 to the base e minus 2 log 2 to the base e. So this is the answer. Now come to the next question. This all we have taken from the uh, Maharashtra textbook. So you can refer all these questions from Maharashtra textbook. Divided by 2x minus 4 the whole square. So here is a multiple. So is a plus log x plus 3 to the base c, and this is all minus 2 minus x minus 4. Now come to the next question. So you have to now in single logarithm. So first you put in power. So log b2 plus 1 to the power 3 to the base c minus r half. So that is half plus 2q plus 3 to the power 5 to the base e. So now this will be p plus 1 to the power 3 multiplied by 2q plus 5 to the power 3 to the power 5 divided by r to the power half. So this is the now 15. Find the domain of the. So what is domain? Domain is x lie between what? So we know that x minus 5 should not be negative. That means x should not be less than 5. So if we plot in number line, then it's a 5. It should be always greater than. So x minus 5 should be greater than 0. That means x should be always greater than 5. So 5 to infinity. So this is the domain. 5 also not included, and infinity is undefined, so that is also not included. So we'll put this one, a small bracket. If 5 would have been included, then we have written like this, but this is not the case. So we should write a small bracket. A small bracket means 5 is not included. Now come to the next question. Here 3 to the power 4 of 3 to the power 2 to the base 4. So now 4 log 3 to the power to the base 4 and 2 log 3 is to get cancelled is 2, so answer will be 2. Now come to the some mistake in this question. What is the mistake? Okay, here, see, one term is missing. Actually, in B between, one term was there. That is 3 P. This the term. This term was missing. So 3 2 ja 6 and 6 5 ja 30. So here 4 will come here. So let's see, 4 will come here. So 8, and this is B A log A to the base P, and 2, this 5 will come here, and to log C to the base A. Here log, this is actually B. This is B. B1. This is B. Yes. This is A, A, A C to the power. No, no. This is C. C. So what will happen? 5C A. And this one 3 E B. So 8 5 ja 40, 43 ja 120. So 120 into log E A. Log A to the base B, log A to the log B to the base, log A to the base B, log C to the base A, and here log B to the base C. Okay, so now what to do? So you take something in between. Suppose we take E. So base change formula. So log A to the base E divided by log E to the base E. We can write using base change formula. So log C to the base C and log A to the base C into log B to the base C into log C to the base C. So this get cancelled, this also get cancelled, and this also get cancelled. So answer will be 120. So here we are using base change formula, and we are introducing E in between. Now find the domain of this one. So x minus 5 and x square minus 4. So x minus 5 should not be, it should not be less than 0. It should be always greater than 0. So x should be greater than 5. And here x square minus 4 should be greater than 0. So x is greater than 4. That means x should be between x should be less than minus 2, and x should be greater than 2. X should be greater than x should be greater than 2. That means x should be greater than 2 and x should be less than minus 2. So this is the yes. But here x all should always be greater than 5. So intersection of both means 5 to infinity. So that will be the answer. This is the domain. So x plus 5. Is x plus 5 or x minus 5? Sorry, it is x plus 5. So x plus 5 means x should be greater than minus 5. So then what to do? X should be greater than, so it will be minus 5 to 2. X should be greater than minus 5 but less than minus 2. But less than minus 2. X should be greater than minus 2, less than, plus x should be greater than how much? 2. So x should be greater than. So this is the answer, union of this one. So this type of question is asked. Thank you.